This particular video is going to focus on speakers and zero in on a particular kind of speaker, because that is the focus of our attention for this particular week. We'll talk about loudspeaker systems and then look at one particular kind of arrangement or construction for a speaker. We're going to jump over here to the PowerPoint once again and identify there's some aspects I want you to understand generally about loudspeakers, and then I want you to really understand how at least one kind of loudspeaker operates, and it's one that should sound familiar to you. So first thing up, we want to make sure we understand that loudspeakers are thought of as a transducer. We've talked about transducers before when we talked about microphones, and so it shouldn't be a surprise to us that when we're talking about the other end of this audio spectrum, of this sound chain, we're going to be talking about some kind of equipment that works in a similar way, but of course in the opposite way, where a microphone took an acoustic energy, converted it to mechanical energy, and then to electrical energy. The opposite is happening with speakers. You know that that's the microphone framework, and so speakers are going to be doing that work of converting electrical energy to mechanical energy to acoustic energy. The electrical energy is what's being provided to the speakers, and eventually we'll be able to hear the acoustic energy as the speakers make vibrations in the air molecules that reflect something that we recognize as sound. So let's think about this overall. When we think about speakers, we think about these parts of speakers called drivers. So drivers are part of the speaker system that are actually responsible for the movement of the air. And we have some different kinds of drivers generally in speaker systems that have more than one driver built into them. Sometimes we have a speaker with just one driver, just one cone that's there. You usually can see it. But many times we have multiple elements, drivers, within a speaker system so that each one can be designed to better capture or represent a range of frequencies through that sound spectrum. So what do we mean by different kinds of drivers? Well, we're often looking at three kinds of drivers. One is the woofer. The woofer is the driver that's responsible for the low frequencies and is going to be the largest of the drivers. The bigger cone allows it to move more air, and if we move more air, it makes it easier for us to represent those lower frequencies with the long wavelengths. The mid-range is going to be representing, much like it suggests, the mid-range frequencies. It's going to be middle in size compared to the woofer and its companion, the tweeter, but it's going to be designed so that it can move a good amount of air, but it's going to be able to move back and forth a little more quickly, and that means it can represent those mid-range frequencies which have shorter wavelengths than those lower frequencies. And then, of course, the other one, the tweeter, as I mentioned, that represents the high frequencies. And so usually this is very small, and that diaphragm is very thin, and it's designed to move small amounts of air but be able to vibrate back and forth very quickly in order to capture that very narrow or small wavelength associated with those higher frequencies. This particular graph here gives you a sense for how the different drivers are going to represent different frequencies and how they work together. So the pink area, the pink line in this graph, represents the low frequencies. So it represents what the woofer is responsible for producing. The blue one represents what the mid-range is responsible for producing. And the red represents what's happening as a result of the high-frequency tweeter. And so the black is giving us what the composite would be, how the sound is representing the all spectrum from 20 to 20K, but together with all three working in unison or working simultaneously. So those are the different kinds of drivers. Now I would like to zero in really quickly on a topic related to one kind of driver, and that is the moving coil driver. The question is, how might this kind of driver operate? And you have a reference point, I think, at this point in the course. You understand that there is a microphone called a moving coil microphone that operates in a way that reflects sound coming in, moving a diaphragm with a coil attached in a magnetic field, generating electricity. So moving coil driver is working the opposite way, right? What we're getting is electrical signal coming in. It's going through a coil. The coil's in a magnetic field. That electrical signal in the magnetic field causes it to move. It'll move forward or back depending on the direction of the electrical signal that's passing through the coil. Here we have some components. Now this is more components. I'm not going to ask you to memorize all of these pieces. I have 6 that I will note in the next slide that I would like you to know. But these in particular, I'll highlight the fact that we've got this 6 number here, surround. That is going to be the piece that attaches the cone to the basket. Then we've got the spider, which is attaching the cone to the coil, and they go in the basket. And then there's that magnet in here. And so when we put all these things together, what we end up creating is an opportunity for an electrical signal to be occurring within a magnetic field and generating movement of that cone in a way that reflects the energy that's coming through the coil. And so that's how we're reproducing the sounds that we've captured with our microphone and that we've stored or are now distributing through our perhaps console into monitors, etc. Here are the 6 items I'd like you to at least be aware of. The flexible cone or diaphragm, that's the equivalent of the diaphragm in the mic. The suspension, so that's the surround, that's the part that's holding it onto that basket. The basket is the framework for it. The spider is that little bridge between the coil and the cone. Of course, we need a voice coil, and then finally we need a magnet. So those are the parts that I'd like you to have, a pretty good understanding of with regard to these moving coil microphones, moving coil speakers, moving coil mics. I'm always thinking about microphones. So quickly, in terms of a summary, we've talked about the system of a loudspeaker, which is primarily working as a transducer. We're taking electrical energy, converting to mechanical energy, and then to acoustic energy that we can listen to. We do have some different drivers that make up this loudspeaker system. Woofers addressing the low frequency, mid-range addresses the mids, and tweeters address the highs. And what we do is we have them as a composite. Each of them takes its area of frequency range that it's going to be able to reproduce better because of its structure and design. And the composite allows us to capture and reflect a wider range of the audio spectrum. And of course, the moving coil driver is one example of the way in which these kinds of speakers transduce that energy.